After you finish creating a table, creating a view, the next thing you want to do is you probably want to start populate data into your tables. At this point, you need to start using another type of SQL language, which is called DML, data manipulation language. The data manipulation language includes a number of the commands that will allow you to manipulate the data in a database table. For example, insert statement is one of these statements, and it's used to populate the database by inserting data into a table. And there are a number of different versions of the insert statement. Here in this slide, we have listed 3 different types of insert statement. One is to directly insert data into a table. And then if you're inserting a record that has some null values for attributes, then there is another way to insert the data. And then you can also insert the data into the table by getting the data from another table. So these are the 3 different insert statements. Let's take a look at the first one. The first one, insert into customer table. So insert into would be the keywords to use in this statement, right? And then followed by the name of the table. In this case, customer table. Okay, values, again, another keyword must be there before you specify the data you want to insert into the table. Then, followed by values, within the parentheses, you have the data that you want to insert into this table. And in this case, we're inserting data into the customer table, and the 001, I assume that's customer ID, and then followed by probably the customer name. In this case, the customer name is Contemporary Casuals, followed by the address and the city, state, and the zip. If you're using this version of the insert statement, one thing you want to pay attention to is the order of the data you have in the statement must be in the same order as the order of the attributes defined in the table, which means in the table you must have customer ID first, then followed by the name of the customer, followed by the street address, city, state, and zip code. Otherwise, it will not insert correctly. Especially if you are trying to insert the wrong data type into the field, then SQL is going to give you an error message. But if the data type matches, but you're entering the wrong data into the wrong field, then it's probably not going to give you a syntax error and will accept the data, but the problem is your data will not be correct. So that's something you want to pay attention to when you use this particular type of insert statement. The second version of the insert statement is somewhat different from the first version. Take a look at the second insert statement here. Insert into product table, right? So same thing. You use the keywords insert into, followed by the table name. Then, following the table name, you are specifying field names of the field in which you are inserting data. So in this case, we are going to insert data into the product ID, comma, and the product description, comma, product finish, comma, and the standard price, comma, and the product on hand. So these are the fields in which we are going to insert data. And followed by the keyword values, right? And then followed by the data you're going to insert into these fields. So again, the order of the data must be in the same order as the fields listed here. The advantage of this version of the insert statement is that it's more flexible than the first version of the insert statement. This way, you can skip a few fields if you don't want to insert any data into these fields, as long as you don't specify them in the list here. If you are not inserting the data in the same order as the order of the attributes, you can also have a different order for the fields. So that's the second version of the insert statement. And then the third version of the insert statement is to insert the data from another table. This is especially useful if you're trying to create partitions for the tables. Like for example, in this case, you have insert into CA underscore customer underscore T, like that. I assume it means California customer table. And the select followed by a select statement. Select asterisk means everything, all the attributes, from the customer table where the state equal to California. Okay, so basically when this insert statement is executed, it will execute the select statement first. It will select all the records from the customer table where state equals California. So it will get a list of customers who are from California. And then it will insert all these records into a new table called the CA customer table. So this is a very useful command if you're trying to create partitions of a table. So this way you can create a partition of the table for customers in California and create another partition for customers in other states. So that's a very useful statement to know if you want to insert a large number of records relatively quickly. The next statement I'm going to show you is something called identity column. Some of you probably have had experience with Microsoft Access. When you create a database in Microsoft Access, there is a data type called auto number. When you use this particular data type, what will happen is it will automatically assign a number to this field. It will increment by 1 every time a new record is added. It will start from a 1, and then the next record will automatically have the value of 2 in it, and so on. In SQL, there is a type of column called identity column, which is the same concept as the auto number. Here, when you create this field in the table, what you do is, you just define the table as an integer data type. In this case, customer ID integer, right? And then followed by the statement generated always as identity. So this shows that this column is an identity column. And you also have the flexibility to state a start number and a maximum value and a minimum value, and also the increment for the identity column. In this case, you want to start with the number 1 and increment by 1. So for the next record, it will be 2 and 3 and 4 and so on. And then the minimum value will be 1 in this case, which is the start value. And the maximum value here will be 10,000. In this case, you can have, including 1, you can have 10,000 records basically in this table. And this is no cycle, which means after you reach 10,000, you will not go back to 1. What will happen if you have 10,001 records in this table? Database management system is going to give you an error message. Right? And when you insert value into this table, you do not have to insert any value for this field, right? Because it will be automatically generated. So just to skip that field when you use the insert statement. Another data manipulation language statement that's very useful is the delete statement. Once you finish populating the table, you may want to delete a few records from the table. To use the delete statement, it's pretty simple. The syntax is delete from, and then followed by the table name, and then the where clause to state the condition. So in this case, we have delete from customer table where the state equal to HI. I think it stands for Hawaii. So it will delete all the customer records for customers from Hawaii. But then, if you want to delete all the rows, all you need to do is just delete from, then followed by the table name without the condition. So if you don't put a condition there, then it will delete all the records in the table. So that's something that you really have to pay attention to when you use the delete statement. If you forget to put the condition, it will delete all the records in the table. And sometimes that may not be what you want. If you don't want to delete all the records, make sure you put the where clause to state the condition of the deletion. Then the next data manipulation language statement we're going to talk about is the update statement. It will modify data in existing rows. You use the update statement in many different conditions. For example, the customer changed his or her address, so you need to do an update for the address field. In an e-commerce situation, when the customer places an order, you need to update the inventory number, you need to update the order number, and things like that. So update statement is very useful in many situations. Well, the update statement's syntax is also pretty simple. You use the keyword update followed by the table name And then you use the keyword set, followed by the field name of the field that you want to update. And then equal to, followed by the new value. If you want to update just a single record in the table, there will be a where clause to state the condition. So in this example, we have update product table, set the unit price equal to 775, where the product ID equal to 7. So what we are doing here is we are updating just one record in the product table, and we are updating the record of the product whose product ID is number 7. And the field that we are updating here is the unit price. We are changing the unit price to 775 and replace whatever the unit price was. So that's the syntax of the update statement. Okay, what if you don't put the where clause here? What will happen here? It will update every record in the product table and set the unit price all to 775. So that's again same thing with the delete statement that you need to pay attention to. If you don't want to update all the records, then make sure you have a where clause here. If you forget to put the where clause, it's going to update everything in the table. Let's talk about this merge statement. A merge statement is a relatively new statement in the SQL standard. It's developed for the SQL 2003 standard, and it's quite useful in certain situations. What merge statement does is it will update a master file by either updating the record or inserting new records. In which situation are you going to use the merge statement? Let's say in your company you have a master data file called a product table. When you purchase new products from suppliers, you do not make any update or insertion into the product table directly because this is your master data file. Okay? And you don't want to update this table directly every time you purchase a new product. So what you do in your system is you also have an update data file. And in this case, it's called a purchase. So in the purchase data file, you'll record all the new products that you purchase and at which price you purchase the product at. At the end of the day, you have this purchase data file with all the new transactions. Now, at the end of the day, you want to update your product master data file by incorporating all these new transactions into the product table. And what you will find out is, well, there are a few products you already have in the product master data file. However, you purchase them at a different price. You need to update the price for these few products. And then there are new products that you never purchased before, but they exist in the update data file, the purchase table. So you need to insert these new products into the product table. So to record that now you have these products in your inventory. So this will require basically two actions. One is to update, like update the price for existing products. Right? The other action would be to insert new records for new products. Okay, so how do you achieve these two results simultaneously with one action? What you can do is you can use the merge statement. So as you can see here in this statement, say merge into the product table, okay, as prod. By the way, as prod here, this is just creating an alias for the product table. In the future, you can refer to the product table as prod, P-R-O-D, instead of spelling out the whole product underscore T. Okay? And the using, and then followed by a select statement, we are going to select all these fields. I select product ID, description, finish, standard price, product line ID from the purchase table as purge. Again, it's an alias for the purchase table. Right, purge. So what you're getting here is you're getting all these fields from the purchase table on prod.product ID equal to purge.product ID. So what we are doing here is we're trying to match the product ID in these two tables. When matched, they update. What it means is when there is a match, which means, well, the same product appears in both the product table and the purchase table, right? We are going to update the existing record on the product That's why it says when matched, they update. So the product dot standard price equal to purge dot standard price. So we are putting the new price in the field for the price in the product table. And then when not matched, right? When there is not a match of the product ID, which means, well, the product ID does not exist in the current product table. So it means it's a new product, right? Then insert. So we're going to insert a new record. So what are we going to insert? We are going to insert into these fields: product ID, description, finish, standard price, and product line ID. What values are we going to insert? Well, followed by values. We are going to insert the values from the purchase table. So the purge.product ID, purge.product description, and so on. So as you can see, it's putting the update statement and also the insert statement into one statement here. By using this merge statement, you're doing both the update and the insertion. The next data manipulation language we are going to talk about is the select statement. That's probably the most useful and versatile command you will see in the SQL statements. And it allows you to query the database, which means you ask the database questions and get results from the database. You can ask a database pretty much anything you want. You can ask, give me a list of customers who purchased the product X during period Y. You can ask the database to calculate the number of customers you have, count the number of customers you have in a particular state. Or you can ask the database to give you a list of customers who have never purchased from your company before. So you can ask the database pretty much anything using the select statement. That's why we say it's probably the most useful and the versatile SQL command in the SQL statements. And the select statement is relatively easy to use and easy to learn. As you can see, these are the different clauses that you will see in the select statement, like select, from, where, group by, having, and order by. So as long as you understand the use of these clauses, you know how to write a select statement. So select statement also is very similar to natural language, English, right? So it's very easy to understand and it's very easy to write. However, sometimes it can be somewhat misleading because it's very easy to write a select statement that's correct syntax-wise. But it doesn't mean that the select statement you write is the correct one. What I mean here is, well, you may be able to write a select statement that will not give you any error messages. But it doesn't mean that you are getting the right result from the database. So that's something you have to pay attention to as a programmer or database administrator. You have to make sure that you test your select statement and make sure that you are getting the right result, not just the right syntax. Let's take a look at these different clauses in the select statement. The first one, select, it will list the columns that should be returned from the query. So the select clause is followed by a list of field names of the fields that are going to be returned in the result. So let's say if you want to get a list of customer last name, first name, and address. So what you do is you will write select followed by the field names, like customer last name, customer first name, customer address, so followed by the field names. And by the way, these field names have to be exactly the same as spelling of the field name in the table. And then the second clause, from clause. From clause indicate the tables or views from which data will be obtained. In the from clause, you will put down the table names or view names where you can get these fields. Let's say, for example, the last name, first name, and address of the customers can be obtained from the customer table. So from customer table. And sometimes you may need to get the data from multiple tables, right, which we will discuss in chapter 8 about querying multiple tables. But anyways, from clause is to state the tables or views where you can get the data from. Then followed by the where clause, and the where clause will state the condition. It will indicate the conditions under which a row will be included in the result. For example, I only want to get the customer records of customers who are from Hawaii, where I can state a condition that says state equal to Hawaii, HI. One thing I want you to pay attention to here is state equal to Hawaii, and also I put single quotes around HI. And this is for character field. If it's a character field and you want to match a character field, you want to make sure that you put the single quote around the string. Here, the select clause is a required clause for the select statement, obviously. From clause, in most cases, it's a required clause. You actually can have a select statement without a from clause. Where clause is an optional clause, which means, well, sometimes you may not have a condition here. Okay, if you only have a select statement with select last name, first name, address from customer table, and if you end here, what will you get? Well, you will get a list of records of customers, last name, first name, address, right? All the records from the customer table. Where clause is an optional clause. You don't have to put a where clause there. And then group by, having, and the order by, all of them are also optional clause, which means you don't have to have them in the statement. They are only used when they are needed. So the group by clause will indicate categorization of results. Having clause indicates the conditions under which a category or a group will be included. Okay, so having is really the where clause for a group. Order by, the last clause here, will sort the result according to specified criteria. So that's basically what a select statement looks like. As you can see, it's relatively easy to understand and relatively easy to write. There are a lot of different variations of the select statement that we are going to talk about in this chapter. The next slide here shows you the SQL statement processing order. It's important to understand the processing order for the performance reason, because a SQL statement can be actually, for most of the SQL statements, they can actually be written in a number of different ways. There are a number of different syntax you can use to write the same SQL statement. So if you understand the processing order, it will help you write SQL statements that have better performance. Let's just quickly go over this. When the SQL statement is being processed, the first clause that's being processed in the select statement is actually the from clause. Why does it process the from clause first? Well, because in order to get the records, they have to find the right table. So that's why it's always processed the from clause first to get the right table. And then, if there is a where clause, it will process the where clause next. If there is not a where clause, it will look for a group by clause, see if there is a group by clause or not. And if there is a where clause, it will process where clause next. If there is a group by clause, then it will process group by after the where clause. And then, if there is a having clause, it will process the having clause after the group by clause. One thing you should remember about the having clause is that if there is a having clause, there has to be a group by clause. You cannot have a having clause without the group by clause, because having is a condition for the group. So without the group by, you won't have any groups. After processing the having clause, it will go back and process the select clause to select the right fields. Okay, and then the last clause it will process is order by to sort the result. So that's the processing order of the SQL select statement. Let's look at a few more examples of the SQL statements here. If you look at this slide here, we want to find products with standard price that's less than 275. To write this SQL statement, right, okay, we are going to list the products, right? So we're going to select, followed by the fields that we are going to list in the results. We are going to list the product name, and we are going to list the standard price. From, followed by the name of the table from which we can get these fields. And both of these fields can be obtained from the product table, or the product view in this case. The V stands for view. A view is the same thing as a table. And where, so followed by a condition, right, where the standard price is less than 275. What does the result look like in this case? Well, the result is going to be a table with two columns. The first column will have product name, right? The second column will have standard price with all the products that have a standard price that's less than 275 listed in this table. Because there is no order by clause here, so the result is not going to be ordered by anything. It will be listed in the same order as the table. Then let's look at another example here. Well, in this example, we are going to use alias for the table name and also the field name. Okay, select cust.customer. So what's that cust.customer? Well, one thing about the SQL statement is that it does not allow any ambiguity. What do I mean by ambiguity? Well, let's say in this particular situation, we have a number of tables. We have the customer table. We also have the order table. In this case, the customer table has a one-to-many relationship with the order table, right? One customer can place multiple orders. From a previous chapter 5, we talked about when you transform the ER diagram into tables, there are a number of rules you have to follow. When you see a one-to-many relationship, what will happen is the primary key of the customer table, which is the customer ID, will be the foreign key in the many side. So the customer ID will appear in both the customer table as the primary key and in the order table as a foreign key. When you're selecting the customer ID field, or a field that appears in multiple places in the database, you have to specify which table you are getting this field from. So that's what this is talking about, .customer is about. Before the dot here, you have the table name, right? And after the dot here, you have the field name. So this is showing that we are getting the customer field from the cust table here. And in this case, the cust here is actually an alias. As you can see here from the from clause, from customer_v, followed by the alias cust. By putting this alias here in the future, when we refer to customer view here, we only need to put cust instead of typing in the whole thing here. This is referring to this actually. So we're selecting the customer field from the customer view as name. Okay, so what this is doing as name here is that we are assigning an alias to this field here. As name, what this will do is when we get the result for this query, it's going to give the customer field a new name called the name. So this name will be shown as a field name in the result. And also the cust.customer address from the customer view, where the name equal to home furnishings. So basically what it will do is it's going to give you a result that looks like this. It will have two fields in the result. Under the name field, it will have home furnishing, and then the other field will be customer address. So you can assign an alias to either the table or to the field. When you assign an alias to the field, you need to put the word as in front of the alias. When you assign an alias to the table, you just put an alias after the table name. Another thing I want to talk about here is how to use the wildcard character. It's very useful in search. There are a number of wildcard characters that are accepted in the SQL statement. For example, the asterisk. It's basically referring to all the fields, right? So if you do like select asterisk from customer table, what it will do is it's going to return all the fields from the customer table. So that's what asterisk is. It's basically referring to everything. However, you don't want to use it too frequently because if you are retrieving every field from the table, you're using up a lot of computing power. especially if it's a large table. Try to avoid using this as much as you can. Only select the fields that you need to use in your result. Another wildcard character is the percentage sign. A percentage sign refers to a collection of characters, right? So it can be anything. So for example, if you have a statement, select asterisk from customer table where last name like followed by single quote and the percentage sign Jones. So what we have here is the condition says last name like single quote percentage sign Jones single quote. So this condition basically says I'm going to pick all the customers whose last name includes the word Jones in it. Because the percentage sign basically means it's a collection of any characters. In this case, if the percentage sign is in front of the word Jones, then it means that the collection of characters has to appear before Jones. You can obviously add another percentage sign at the end, which means Jones appear somewhere in this last name. And also the other thing I want you to pay attention to is like here instead of equal to. Equal to means you have to have the exact match. Like here means it must include these characters in the field. Underscore is another wildcard you can use. And underscore is referring to just one character. It can be a number or it can also be an alphabet. So for example, we want to select everything from the customer table where the last name like single quote underscore MITH and the single quote. If somebody's last name is Smith, then this person will be included in the result. So because it's saying that before MITH, there should be one character. So these are some of the wildcard characters that's accepted in the SQL statement. The asterisk, the percentage sign, and the underscore. In the previous slide here, we also have a list of operators that are used in the SQL statement. You're probably familiar with most of them. Equal to, greater than, equal to, less than, equal to. For not equal to, there are two formats here. One is the less than and the greater than sign together. And the other one is the exclamation mark and followed by an equal sign. So you can use either one of these for not equal to in the SQL statement.